Hi, my name is Bernardo Guzman, and this is Cat 1 ATP Pathways for my exercise physiology class at Cal Baptist University. And we are going to be talking about two molecules in particular today, one being glucose molecule and the other being palmitic acid, or lipid or fat, whatever you want to call it. We're going to be discussing how the breakdown of glucose is going to be turned into ATP. So that all starts with the process called glycolysis. And as you see here, the carbons, or the C's listed in the diagram, are what create glucose. And this is a chemical chemistry there, but most molecules are made through carbons and hydrogens and nitrogens. So glucose is consisted of 6 carbon molecules. Once breathing is initiated, and that's the key word. Breathing is important because none of this happens unless we are breathing. So, in the process of this, 2 ATP and 2 phosphate groups are then introduced to glucose once glucose has entered the cytoplasm from the bloodstream. So this is floating around in our blood, and once exercise, then being the initiating and a stimulant, will kind of flood it into the cytoplasm, and now we have energy being converted. So in this process, the glucose molecule is energized and creates 2 phosphate molecules to the actual carbon glucose molecule. This allows that carbon molecule glucose to separate into 2 phosphate groups, which will be later on discussed as to what those 2 phosphate groups are used to assist in making energy. We're going to continue from the top here, but basically, as I discussed earlier, the glucose molecule enters the cytoplasm from the blood. 2 ATP are used for energize through the glucose. Glucose splits into 2, and these 2 3-carbon molecules are made. Each 3 carbon molecules gives you a high energy electrons and hydrogen to make NADH. Now the NADH creates 2 ATP. These ATP molecules are used later on to be put into another energy system. So because of these energy systems being created, you now create a pyruvate. A pyruvate is important because it's later on used in another energy system that later on is going to create the ATP needed for us to move. The NADH carries energy to the mitochondria to be used in the electron transport chain, another energy system. We're going to talk a little bit about the citric acid cycle / Krebs cycle. We're going to go into what happens to pyruvate, and pyruvate dehydrogenizes and turns into acetyl-CoA. Along the way, there are additions and subtractions of NADH and hydrogen. As you can see here, it goes through an 11-step process that's needed to basically rehydrogenate and dehydrogenate acetyl-CoA. In these processes, hydrogen is given up and phosphates are given up. These subtractions and additions are what create the ATP needed for us to use in this particular instance exercise. So we're going to touch back a little bit on the next molecule, and this being palmitic acid. So palmitic acid is a 16-chain carbon. As I stated earlier, the glucose molecule is a 6-chain molecule. So for no coincidence, the larger yield carbon chain in palmitic acid carries a lot more energy that we can use for exercise. However, because it creates more energy or more ATP doesn't necessarily mean it's the most vital part or more important part to use. Depending on the intensity and the duration of exercise will determine what energy system is going to be used and when it gets used. Basically, the breakdown of ATP, or in this case, the creation of ATP from the fatty acid, palmitic acid, goes through 7 rounds of beta oxidation and 8 rounds of acetyl-CoA are formed. the top numbers here. So you can see the bottom numbers and the top numbers of that. So 7 rounds of beta oxidation, meaning the addition of oxygen, creates energy. So 7 rounds of FAD, which is a hydrogen yielding molecule. 7 rounds of NADH, which is what we saw in the Krebs cycle of what goes on and what gets attached. So these are transport molecules that are used to create ATP. Now, as we discussed in the Krebs cycle, or in the citric acid cycle, 1 round of glucose goes through 1 round of that cycle. However, for a palmitic acid, that goes through 8 rounds through that Krebs cycle, creating a large amount of ATP. You combine all these creations and you get 130 ATP. However, it does take a longer duration to create this, and it usually takes about 30 minutes of a person exercising until you actually start using this form of energy. However, glucose only creates 36 ATP. Each of them serve a purpose, and we're going to go into that, and we're going to dive into that when we go into why is important, or application to the real world. Understanding the duration and intensity of a workout will dictate usually when the energy is going to be used. If you're going to be sprinting, you do not want to create slow, steady energy like it's being used in palmitic acid. You're going to want to generate speed and force, whether you're in Olympic lifting, whether you're cleaning or snatching or squatting or sprinting. You're going to want the energy at, instantaneously, and that's what glucose is there for. And it's the simple building blocks of our body, and it's the easiest way to get energy from. However, we may not be able to hold that intensity forever. Let's say if we're running a marathon. If we're running a marathon, we're going to want the energy to be released slow and steady. Now, there is a trade-off, though. You will have to go through some type of lactate thresh, and that can be later on talked about more. But at the end of the day is basically what and when you use the energy systems are going to be constantly be interchanged. You're not only going to be in one specific energy system. You're going to come out of glycolysis all the time. You're going to come out, and that's why it's important sometimes for marathon runners to rehydrate, not just with water, but with some type of glucose source, so that you can use that fast yielding energy, like glucose can be for you, compared to using the lipids or fat molecules, as described in the beta oxidation for lipids, and in this case, palmitic acid. Greater yield, longer duration, faster yield, quicker and higher intensity. And that's kind of the end result of both of these energy systems. So 2 types of energy, both go through the whole process. And as you can see in this slide right here, pyruvate, when you're in the beta oxidation, or you go through not beta oxidation, but when you go through the acetyl-CoA, basically that's going to get put into the Krebs cycle here, and you're going to go through 8 rounds of that, and that's going to yield you a large amount of ATP. So thank you, and I hope you understood my presentation on glucose and on palmitic acid. Thank you, and have a good day. Bye.